Hello, everyone. Welcome to this installment of NASA's Applied Remote Sensing Training Program Pre-Training Tutorial Series. These short video demonstrations help you to get set up to actively participate in upcoming RSET trainings that require you to access code stored on GitHub, while also priming you on the core concepts of version control software. Version control software allows you to work with multiple iterations of your project, track changes, and streamline collaboration with others. Most importantly, this is how you can access code and data required to follow along with RSET trainings. Git is a very popular system for version control, and its relative, GitHub, is an external bank of servers we can interact with through Git to send and receive versions of our code. We will only be using Git in this demo, but note that there are other version control systems such as Mercurial and Subversion, each with their own particular nuances. Version control software is also usually paired with a remote storage system consisting of an external host server, such as GitHub. Here too, note that we're only talking about GitHub today, but there are many other platforms that you might use for managing your remote storage, such as Bitbucket, GitLab, and the various cloud service providers. RSET trainings will share code and documents with training participants through GitHub. By the end of this video, you should have the skills you need to access those files and work with them on your own computer. In this demonstration, I'll show you how to copy code from an existing repository by cloning the files onto your own computer. A future training will look at creating a new repository in GitHub, cloning, adding, changing files, and sending or pushing those changes back to your remote repository. I'm working on a virtual machine running the Windows 10 operating system. However, all of the commands we'll be discussing are the same across all operating systems with Git installed. So if you're working on a Mac, Linux, or other Unix-like operating system, you only need to install Git and use your regular terminal window and bash shell to issue Git commands. Git can be installed via your operating system's regular package manager. I've already created a repository in the NASA RSET GitHub that we can use for testing. This is a public repository, which means that anyone on the internet can find and download the information contained within. Note that there are also private repositories, which only you and approved collaborators can access, but those are not covered in this module. The repo we're going to focus on is called Super Awesome Repo. I am going to copy the URL address for this repo into my clipboard. Now, open Git Bash. On Windows, I can find my Git Bash application by clicking on the Windows logo and typing git. Again, if you're not using Windows, this would just be your regular terminal window. This tool, Git Bash, gives me a Unix-like interface to the Git utility, which is to say that from this point forward, the commands are identical regardless of what operating system you're using. Now, navigate to the folder, also called a directory, you want to copy this repo into. If you don't already have a folder you'd like to use for this, go ahead and create one now. I want to send mine to a directory I've already created called projects. As you can see, I don't have any folder named Super Awesome Repo in my projects directory. To make this more clear, I can open this same location in my file explorer. And going back to our repo on GitHub, you can see that in the remote repository, I only have one text file called importantinfo.txt. Our goal is to copy or clone the remote repository to our local machine so that we have a new folder and the text file it contains. Going back to our terminal window, type git clone, and then paste the URL. Hit enter, and after just a moment, you'll see a confirmation message which begins cloning into the name of the repo and so on, and you'll see at the end, receiving objects, 100% done. If instead you see lines that say something like repository not found or fatal repository and then a URL not found, you should check that the repository you're trying to access is public and that you've copied the URL correctly. If you see a message saying fatal, destination, path, etc., then you'll need to check that you haven't already created a directory with the same name as the repo we're trying to clone in the destination directory. Going back to check our projects directory again, we can confirm that there is a new subdirectory called Super Awesome Repo, and inside that folder, there should be a single text file. This exactly matches the state of our remote repository at the time that we ran the clone command. If we want to get the newest version of the remote repo at some time in the future, we can drop into the folder for our local version and simply run git fetch. This is useful because the owner of the remote repository and other collaborators are likely making changes to the remote repository over time, such as fixing bugs or adding new features. When the remote repository is updated, your local copy is not automatically brought up to date. To retrieve the latest version from the remote repository, you'll need to run git fetch. Those commands, clone and fetch, allow you to copy code from remote repositories and keep your local version up to date. When copying code and data from GitHub for the purposes of an RSET training, these are the only commands you're likely to need. However, this only represents one direction that data can travel, from the remote to your local machine. A second part of this video tutorial will teach you how to manage your own repositories and collaborative coding environments. Thank you.